Good morning, grade 8. How are you today? I hope you are fine. Today we're going to continue the second part of the lesson that we have started on Thursday, chapter 10, lesson 3, data distributions. First, I want to review fast some expressions that we have learned on Thursday. The first one is mean, is the average of the data values or the sum of the values in the set divided by the number of values. So it is the sum of the values of the set divided by the number of values. Median. Median is the middle value when the values are in numerical order, or the mean of the two middle numbers if there are an even number of values. If I have an odd number, so the middle number. And we learned how to do it, that we're going to cross from left to right, one by one, and the one that is in the middle is the median. If I got two numbers in the middle, so I will get their mean. Their mean means I'm going to add them and divide by 2. The mode is the value or values that occurs most often. It can be one value or many values. The range is a set of data, is the difference between the greatest and the least. The difference between the greatest and the least. And we solved some problems for this one. And we're going now to learn another thing which is called a box and whisker plot. Let's go to page 704. Okay. What is the box and whisker plot? In the beginning, you feel it's a little bit complicated, but when you solve a problem, you will feel it's so easy and so interesting. Okay. Measures of central tendency describes how data cluster around one value. Okay, forget about this one. Let's start from here. Quartiles. This is a new word that we're going to use. Quartile divides a data set into 4 equal parts. Each quartile contains 1/4 of the values in the set. The first quartile is the median of the lower half of the data set. The second quartile is the median of the data set. And the third quartile is the median of the upper half of the data set. So I have 3 quartiles. The first one, and I will get the median. And the median of the whole set is called second quartile. And the third quartile contains the rest of the values, and also I will get their medians. The interquartile range IQR of a data set is the difference between the third and the first quartiles. Is the difference between the third and the first quartiles. It represents the range of the middle half of the data. Okay, let's know more about this. If I have a set of numbers, of course I will put them in a numerical order, which is from least to greatest. And I will divide them. For example, they are how many values? 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. I will put 5 here and 6 here, for example. And 1 will be in the middle. I will get the median for the first group. And I will say first quartile. I will get the median of the first group. And I will say first quartile. And I will get the median of the I will get the median of the second group, and I will call it the third quartile. What about the second quartile? The second quartile is the median of all the set. Is the median of all the set. So I'm going to get 3 medians. Median of the first quartile, median of the second quartile, of the third quartile, and the second quartile is the median of the whole set. What is a box and whisker plot? Box and whisker plot can be used to show how the values in a data set are distributed. You need 5 values to make a box and whisker plot. I need 5 values. The minimum, and here comes the minimum. The minimum value, which is 1. And the maximum, the minimum is here. Okay, the maximum is 9. Okay, the first quartile, which is this one, the median of the first set, and the median is the second quartile, and this one, and the third quartile is the median of this set. So to make the box and whisker plot, I have to get 5 values. The minimum here, and the maximum here. Okay, and the median of the whole set. And the first quartile, which is the median of the first of this set, and the third quartile, which is the median of this set. Okay, let's solve a problem here so it will be more clear for me. Example 4. Okay, the numbers of runs scored by a softball team in 20 games are given. Use the data to make a box and whisker plot. A box and whisker plot. So I have all the numbers here. So what is the first step? Order the data from least to greatest. It is the first step that I have to do in all cases. To order the numbers from least to greatest. Okay, then 2 is the greatest. Then I'm going to list here all the numbers that I have till the greatest number. So 2 is the least and 13 is the greatest. Okay, identify the 5 needed values. Identify the 5 needed values. Okay, before I will identify, I want to make 2 groups for these values. I want to make 2 groups for these values. As you see here, there is a group here. And there is another group here. Okay, girls, how I'm going to make the groups? I have here 2 and 3 and 4 and 5 and 7 and 8 and 9 and 10 and 11 and 12 and 14. And they are repeated. But here are the main numbers, 2 and 3 and 4 and 5 and 7 and 8 and 9 and 10 and 11 and 12 and 14. How many numbers they are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's make 2 groups. The first group has 5 and the second group has 6. So I'm going to put 2 and 3 with the 3 repeated values and 4 with its repeated values, and 5 and 7 with its repeated values. And then the other group, I'm going to put 8 and 9 and 10 and 11 and 12 and 14. Okay, girls, again, how we're going to distribute the numbers into 2 groups. How we're going to distribute the numbers into 2 groups. First, I will count. I have 2. And I have 3. I will not count the repeated numbers. I am counting the main numbers. I have 2, I have 3, I have 4, I have 5, 7, 8, 9, 10, 11, 12, and 14. Do not count the repeated numbers. Just count the main number. Okay, so I have here 11 numbers, so I will put them into 2 groups. The first group is 5 numbers, like this one. And the second group will take the 6th other numbers. So I put here 2, and here I'm going to put all the repeated numbers. And then here I put 8 and 9 and 10 and 12 and 14. So now I put all the values into 2 groups. Then now I can identify the 5 values. Here comes the minimum, which is 2. Here comes the maximum, which is 14. Okay, girls? Here comes the minimum, which is 2. Here comes the maximum, which is 14. Okay, I want to get the median of the first group and the median of the second group and the median of the whole group. The median of the first group. Okay. How I will get the median of the first group? Cross one from here and one from here. One from here, one from here, one from here, and one from here, one from here, and one from here. So what is left for me? 4 and 4. 4 plus 4 is 8. 8 divided by 2 because they are 2 numbers. So it will be 4. So Q1 represent quartile 1, the first quartile, because the first quartile represents the median of the first set of values. The first quartile represents the median of the first set of values. So here I got the third value here. Teacher, when we go to solve, can each two be partner? Not now, Tal. Maybe later. How you will solve with partners now? Wait, I will tell you later. Then I will get the median of the second quartile. Cancel from here and from here, from here and from here, from here and from here, from here and from here. 2 numbers are left for me, 10 and 10, 10 and 10, 20 divided by 2 because they are 2 numbers, so it will be 10. So the third quartile is the median of the second group. The third quartile is the median of the second group, which is 10. Okay, girls? So now I got till now 4 numbers. What is the second quartile? The second quartile is the median of the whole set. Is the median of the whole set. So if I cross one from here and one from here, one from here, one from here, if I keep crossing from left and right, 7 and 8 will be here left. 7 and 8. 7 and 8 together are 15. 15 over 2 is 7.5. 7.5. So now I get the second quartile. The second quartile is the median of the whole set. The third quartile, Q3, is the median of the second set. And the minimum and the maximum. Okay, step 3. Draw a number line and plot a point above each of the 5 needed values. Okay, I will stop here. Okay, so I will draw here a number line. Here from 0 to 14. Why from 0 to 14? Because the maximum number that I have here is 14. So I'm going to plot a number over 14. And I will start from 0 because the least number that I have is 2. So I will start from 0. Then I'm going to plot a point above each of the 5 needed values. I'm going to plot a point above each of the 5 needed values. So the minimum is here. Okay, girls, here comes the minimum. And here comes the maximum. Okay, and I will put here the median, which is Q2, second quartile, over 7.5 because the median here is 7.5. The minimum here is 2, so I will plot a point over 2. The maximum here is 14, so I'm going to plot a point over 14. The median here, which is Q2, is 7.5, so I'm going to plot a point over 7.5. They are all on the same line, girls. I'm plotting them all on the same line. Then the first quartile, Q1, is 4, so I'm going to plot a point here over 4. And the third quartile is 10, so I'm going to plot here a point over 10. So here I got the 5 points. Here I got the 5 points. Okay? I plot them all together on one line, above the number line, not on the number line, but above the number line. Okay, it is above the number line. As you see here, it is above. It is above. It is not on. It is above. What I'm going to do next? I'm going to draw a box through the first and the third quartiles. A box through the first and the third quartile. Here is the first and here is the third. So I'm going to draw a box. Okay? And a vertical line through the median. Here is the median, so I'm going to draw a vertical line. Draw lines from the box to the minimum and the maximum. Here is the maximum. I'm going to draw a line to the box, and here is the minimum, and I'm going to draw a line to the box. Here comes the whisker, the box and whisker plot. Look, girls, it is not hard. It is a little bit long, but really it is interesting. It is so interesting. It is like a game, if you are solving a game. Okay, so I will let you now watch a video.
All right, now there's another way of visualizing, in some sense, a measure of central tendency. And let's take a look at this example where you can see that live. Okay, the number of dogs in Doggy Fun Time daycare over 11 days are given as follows: 15, 5, 7, so forth. All right, what we want to do is we want to sort of get a sense of how this data is spread out. So the first thing I'm going to do is order them in order. So now we can see all the data points from smallest to largest. Now, there are various pieces of this that are sort of interesting. What we do is we cut this data set right in half. And so you'd see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I have two ranges now. 1, 2, 3, 4, 5. So I've got this range, and I've got this range. This upper range, I've got this lower range. Okay, now what we can do here is find these different quartiles. So what we do here is, for the first quartile, what that's going to represent is the median of this group right here. So where is that? That's going to be right here at 7, because that's actually the median of this first group right here. Now the Q2, the second quartile, is actually going to be the median of the entire data set, which is going to be that number right in the center. So there's that. And then Q3, the third quartile, is going to be the median of the second part, the higher part, which in this case you can see is 15. And we have the lower extreme, which is way down here. That's going to be 5. And the upper extreme is going to be the maximum value here, and we get 20. Now we can take all this information and actually produce a visualization of this data. And what would that look like? Well, the visualization of this data would look something like this. We take a number line, and I'm going to put dots at the lower extreme, and then at the first quartile, second quartile, third quartile, and then the upper extreme. So we start with these dots. So that's going to be a 5, then it's 7, then at 12, then at 15, and then at 20. Okay, and now what we do is we place a box around the points that are between the first quartile and the third quartile, and also draw a line right at the second quartile, because that's sort of the center point, and then extend these, well, whisker-looking things. And in fact, this is called actually a box and whisker graph. And so this gives a sense of where the data is clustered. And you get a sense of the clustering of the data by actually looking at this. You can see where the middle of the data is, and then each of the ends of the middle, and you get a sense of the spread, how far things really are spread apart. Whether you're visualizing the data or whether you're actually taking all the data and boiling it down to one number or a couple of numbers, by trying to find a measure of central tendency, we're actually trying to describe the data set in a cohesive, tight, compact way. So
Okay, girls, I hope you get it. I want to answer the second one before the time will be over. Example 5, reading and interpreting box and whisker plots. This one is a little bit easier than the first one because it is already drawn in front of you. The box and whisker plots show the ticket sales in millions of dollars of the top 25 movies in 2000 and 2007. A. As you see here, I have two box and whisker plots, one for 2000 and one for 2007. Okay, here is the minimum, here is the maximum, here is the median, Q2, here is Q1, and here is Q3. Okay, again, in 2007, here is the minimum, here is the maximum, here is the median of the whole set, here is Q, which is Q2, here is Q1, first quartile, median, and Q3, quartile of the second set. Okay. Which data set has a greater median? A greater median. Explain. How I will solve this one? Here, the first year 2000, the median is 125, and the second median, and the median of year 2007 is here. It is almost 160, 170. So which is greater? Of course, year 2007. In another way, the vertical line in the box for 2007 is farther to the right than the vertical line in the box for 2000. If it is farther to the right, so this means it is greater because the numbers are getting greater when they are going farther to the right. So the median, which is farther to the right, is the greater median. Okay, the data set for 2007 has a greater median. B, which data set has a greater interquartile range? Interquartile IQR. What is IQR? If you go back to page 704, you will read its definition. The interquartile range, IQR, of a data set is the difference between the third and the first quartile. The difference between the third and the first quartile. So if I'm going to draw lines here, difference between the third and the first, and difference here between the third and the first. Which difference is greater, the pink one or the yellow one? Here comes the pink one, and here comes the yellow one. Which difference is greater? Of course, the yellow one. So the length of the box for 2007 is greater than the length of the box for 2000. So the data set for 2007 has a greater interquartile range. So what does this mean? That the length of the box shows the IQT, the IQR, the interquartile range. So the box that is greater has the greater IQR, interquartile range. Okay, about how much more means I'm going to subtract where the ticket sales for the top movie in 2007 than for the top movie in 2000. About how much more were the ticket sales for the top movie in 2007 than for the top movie in 2000. Top. What is the meaning of top? Top here has a meaning. Top here has a meaning. Top here means maximum. Maximum. So I'm going to see the maximum here and the maximum here. The maximum here is 300 almost. If I will draw a line down, it is 335, and if I draw a line down from here, it is almost 260. If I draw a line from the maximum to the line plot to read its number, it is almost 335. And if I draw a line from the maximum to the line plot to know its value, so it is almost 260. So how much more means I'm going to subtract. So I'm going to subtract 335 minus 260. It's equal to 75 million because they are all million. So the ticket sales for the top movie in 2007 were about $75 million, more than for the top movie in 2000. Okay, let's watch together this one.
Box and whisker plots allow us to see variability or spread of data. So let's take a look at some data here and look at some box and whisker plots. So here we have two very famous basketball players. So we have Akeem and Michael, and it turns out that here we're plotting out the box and whisker plots for the total points scored for the years 1984 through 1993. And so there's some questions that we want to ask about this, but first, before we even ask the questions, let's just make sure we understand what these things mean. Remember that the dot that appears sort of inside of the box represents the median of the data. This endpoint here to the left represents the first quartile, and this represents the third quartile. So this means that half of the data sort of is spread into here, quarter, and a quarter is here. And the same thing here. They look pretty different. Let's figure out what's going on. So let's take a look at some questions. First, let's compare the medians and the ranges. Well, let's take a look. Well, certainly Michael's median is much larger than Akeem's median. So what does that mean? Well, that means that the average, the most popular, the middle one for Michael is higher than the middle one for Akeem. But what about the range? Well, the range is the difference from the largest to the smallest. You can see that's a much larger difference than this. So it means that in some sense, Akeem's data is sort of more tightly bunched together. In some sense, there's less variability in his data than in Michael's data. Even though there's lots of variability, it turns out that sort of the middle or the median is higher than Akeem's. Now, second part is to compare the ranges of the middle half of the data for each. Well, the middle half of the data, as I've already said, is sort of included in the box here. So this is the range, if you will, from here to here of the middle half of the data. Well, how is that spread? Well, we look at this sort of the length of the box. And just by looking at this, it appears to me that those lengths are essentially the same. So I'd say that the range of the middle half of each of their data, in fact, is the same, because this length of this box is equal to the length of this box, and that length represents the range of the middle half of the data. So the box and whisker plots allow us to see spread and variability in data and allow us to see sort of where the center of the data is and how it's spread out. So while Akeem is much more reliable in that he tends to sort of do things clustered near, Michael is way out there, has more variability, but overall seems to be, on average, a better player. Anyway, I'll see you soon. Enjoy these plots.
Okay, girls. If you read it immediately after you finish all your sessions, you will get it, and I'm sure that everything will be clear for you. Okay, girls, see you tomorrow, and don't forget to answer your homework. And if you faced any problems in solving the homework today, please don't forget to ask me in the beginning of the lesson tomorrow. Okay, girls? Okay, see you tomorrow. Bye.